2 months ago, I did a presentation on web performance. Part 1 was all about caching. This is part 2. So the first one was about kind of server-side performance. This is more about what happens after the server responds. Tell you a little bit about myself really quick. I've been a senior developer at Investopedia for 3 years. It's a fairly big site, 13 million unique visitors monthly, 14,000 active sessions at peak, 800 million page views in 2017. We've merged with another company now, merged into Dotdash. They have several other websites, so now we're about 9 times bigger. And I'm actually on a team, I was on a team that deals with core frameworks for the entire company, and now I'm moved to the security team. So a bit of a shift. But before that, I worked on page speed at Investopedia. So just to kind of level set, I want to spend as much of this talk as possible talking about like real world examples of trying to make your site faster. But I want to level set a bit because a lot of people probably don't know a lot of the terminology and stuff I'll be using. So the first like 2/3 of this are going to be basically the same as you can see in a lot of other presentations about page speed. So I'm going to try to go through those, kind of gloss over things a little bit more, but just give you an idea of what's there. So let's start with a brief overview. What happens when you load a page? So it's really important to understand what's going on in behind the scenes with the browser. So when you type in a URL and you hit enter, it loads the page. What actually happens there? It actually sends a request to a domain name service, to a DNS. It says like, hey, I got this URL, what's the IP? That IP has to come back. Then it makes a request to that IP for the actual document. That web server has to process it and respond back. Once the browser receives that document, it starts parsing it. So there's like 2 round trips there at least before it comes in. Then really there's like TCP negotiation and TLS if the site's on HTTPS. So there's like 5 round trips before you even just load the basic document. And that document is what you see when you view source on the page. It's just that, all that you see in view source, and that's it. So it's not going to download the images, anything like that. That's where we get to step 2. As the browser's parsing through that document, when it goes through everything sequentially, when it sees something, like, hey, there's some JavaScript file I'm supposed to grab, or some CSS, or an image, then it goes and grabs that thing. The fun thing with a lot of these resources, like JavaScript, it will actually pause parsing the document and send out a request for that JavaScript file. And it goes through the same steps. It has to hit a DNS server, then it has to negotiate TCP, then it has to do the TLS. So it's a lot of round trips for each one of those resources. So here's some examples. Like every time you have link, rel, style sheet, that's telling the browser it has to go and fetch a resource. Anytime you have a script tag, generally it's going to fetch a resource if it's got a source in it. Images has to go and fetch those. So why am I talking about all this? Round trips are expensive. This is one of my favorite quotes from Grace Hopper. This is 1 nanosecond. That length of wire, it's about this long, is how far light will travel in 1 nanosecond. So we can do a bit of math on that. From Edmonton to North Virginia. Who can tell me why North Virginia? That's where most people have their AWS servers. That's kind of the default. So it's about, I mean, this is with driving directions from Google Maps, about 3,200 kilometers. It's close enough for purposes here. Speed of light in fiber is around 200 million milliseconds. So that's about 16 milliseconds, just straight line-ish, following the road, from here to North Virginia. So for a round trip, 32 milliseconds. So all those round trips we talked about, that's 32 milliseconds each. That adds up fairly quickly. What about hops through routers though? Because that 32 milliseconds, it's not that fast. It's more like 80 because it has to go through routers. There's no straight cable from here to North Virginia. It's probably going like over to Toronto or something and down, skipping through a bunch of routers in there. So if we want our site to load in 2 seconds, that gives us about 25 sequential round trips. And we're out of time. And with each of those resources, it's multiple round trips. So like, you can't be doing things sequentially. And like I said, there's the TCP handshake, TLS, DNS. Got ahead of myself there. So what should we focus on first when we're trying to make our site faster? Asynchronous fetching, like number 1. That's where I see most sites are failing. They are not worrying about doing things asynchronously. If we're doing things asynchronously, that means as your browser's parsing that document, it doesn't stop ever. It goes through and hits like, hey, I need some JavaScript. Okay, go and get that JavaScript and continue parsing. And that's what we want to happen. So we're asynchronously fetching all these things. Because like I said, 25 sequential round trips. We got to get as much in that time in as we can. The other thing a lot of people tend to look at first is actually reducing the number of resources or the client-side JavaScript performance. Those are important, but if your asynchronous fetching isn't there, you're not going to see a big improvement. Some things that are also important, but I would look at them later. Actually, going back to this one, sorry. Client-side JS performance is not that important if your site's not interactive. If your site's very interactive or you're doing client-side rendering like with React, then it suddenly gets way more important. There's some other things like more performant image formats. Those will help. But again, if you're missing those other three, you're not going to see an improvement. Client-side JS performance, reducing the size of resources, reducing the size of the document. You can do all those things. You won't really see an improvement if you're not doing things asynchronously. So before I get into how to do that, I want to talk about measuring web performance real quick. So we kind of defined what the problem is. How do we measure it? There's a few different measures. Time to first byte is a common one you'll see. So that's the talk I did 2 months ago. That's where you solve time to first byte with a lot of caching and stuff. So that's the request goes to the server and you're starting to get an actual response back for your document. So like the first byte of the document, that's that time. So if that is slow, like you're kind of done. If it takes 20 seconds for that to happen, there's nothing you can do. It doesn't matter what you do with what you're returning. It's taking too long to get it there. So that's an important one, but that's solved in the first part of this talk where you do a lot more caching and get your server response really fast. Time to last byte's another measure I see that I don't see as much value in it. That includes when you're done receiving the document, which actually I know done receiving everything. If you have ads on your site, it's kind of meaningless because ads will screw up everything. First CPU idle is important and time to interactive are important as well. Question?
Sorry, talk about how these relate to SEO.
Yes, these are time to first byte, and I'm going to get to another one after this. The most important one is actually first meaningful paint, which we're going to talk about next. CPU idle and time to interactive are important for sites that are interactive. So like if you have a React like single page app, you're going to want those good because that's when the user can actually start clicking on things. If it's a site like I work on, which is mainly like publishing, people are reading articles, they're not going to notice if it's interactive after 2 seconds or 15 because there's really no interactivity on the site. The big one in nice big text, first meaningful paint. This is the huge one for SEO. It's not the only important one, but it's probably the biggest. So first meaningful paint is the first time you paint something that's meaningful and useful to the end user on the page. This is when it looks like the page is useful. So it might still be spinning and loading things like below the fold. It might be loading a ton of giant ads or something, but the content they want is there and they can start consuming it. It's kind of subjective. There's lots of different tools to measure it, but generally, you know, there's no definitive like this is how you determine when your first meaningful paint is. But you kind of have to look at it from a practical standpoint. When does the page look like it's actually useful? That's really the measure. You might have a tool that says it's 15 seconds, but when you actually load the page yourself, it's popping up instantly. Something there is messing with the tool and confusing it. If you don't care about SEO, that's probably fine. If you do care about SEO, well, if you're using a Google tool, then Google might be thinking your page is really slow too. So you might want to fix that even though it looks fine to you. Getting into some of those tools. Lighthouse. This is a tool that I think was acquired by Google. It's actually built into Chrome now. It's really good at telling you kind of what the biggest impact is on your site. It'll load the page once and just give you a full listing of like, hey, here's all the stuff you need to fix. Pretty awesome. Let's see if I can show that really quick. So if we run on a fast one really quick here. Oh, got one open already. So it looks like this after it's done running. This is our site. You can see we have an awesome 3 out of 100 on this one page. So we've been migrating our site over to Dotdash's infrastructure. This is one of the pages we haven't migrated over yet. And it's a page that the SEO doesn't really matter on. So it hasn't had the love it needs. So you can see how bad things can be. Lighthouse is awesome because it will show you some exact problems here. So we use full page caching. When I loaded this for this example, the page wasn't cached, so it took a long time for the server to respond on that time to first byte. That's killing it right there. Then it tells you, you know, there's render blocking resources. Here's what they are. Here's how long they're taking up. You know, here's some stuff you could defer. So it kind of tells you exactly what you need to do to make things better, which is awesome. And another tool, webpagetestorg. This is the one I see referenced most often. It's cool. You can pick like where you want the traffic to be coming from. You can choose the device. Like you can be like, hey, I want it on an iPhone 5. It'll run the test 3 different times. And the output is this awesome graph that tells you anything and everything about that page load. I could see this being useful to some people. For me, I don't understand most of this. I'll be honest with you. I've never bothered looking into it because I had Lighthouse to look at. And it's like, hey, fix this. I'm like, okay, I fix it, and then my page is better. This, you can dig into like every single thing that gets loaded, when it's getting fetched and things like this. If you really want your site to be super fast, you'll want to be using this tool and digging into every line on this graph and figuring out how you can make it faster. For me, our site was at like 8 seconds, and we wanted to get it down to like 3. So there was just some big things to do, and it wasn't worth digging into all the small things because we weren't going to be able to fix the small things anyway. Another really good tool. This one I don't hear about a lot, and I kind of, like, one of my coworkers mentioned it to me, and I was like, wow, that's really good. It lets you inspect your page, and there's this drop down in the Chrome DevTools. You can go to More Tools, Coverage. And let me bring that up. Reload the page. And it says, hey, this CSS file is, let's see if I can get this, 95% unused. Sorry, 94.6. You know, JavaScript file, 97% unused. That's on page load. In our defense, a little. I mean, we don't. You should be laughing at us, but that's on page load. So like maybe there's things on the page you can click on that actually go through some of that JavaScript, and things will appear on the page. It still should not be this bad. But this is where we were at. This tool is awesome because it tells you these things, which otherwise it's really hard to tell. You can actually click on that file. And if I open this, it'll actually go through all these CSS rules, and that red shows you the rules that are unused, which, I mean, it's 97%, so it's going to be scrolling for a while before I find something green. Yeah, we'll come back to how we can use that tool in a little bit here. So let's talk about making things asynchronous, the big one. You basically put some hints at the top of the document so that as the browser is parsing, it hits these things right away. The reason why is things like a font. You'll usually have inside your CSS file, you'll be like, okay, this should be styled with this font, which is like a URL to some third-party thing. So it'll parse the whole document. It's not until it's like processing the CSS and sees that it goes out and fetches it. So it's happening really late. You can put things at the top of the file like DNS prefetch to say like, okay, I know you're going to be going to this domain as you go through the document and find things. So hey, go and do that DNS round trip right now. So it can do that in the background while it's parsing the document. Pre-connect is even better. It goes and does that DNS round trip, and then it also does the TCP and TLS negotiation, actually connects to that server, so that when it hits that part in the document, it just says, hey, give me this resource. Great. Pre-fetch, even better. So this is where the font one comes in. It's not going to try and fetch that font till way later. Right at the top of your document, you can say, hey, go and fetch this font right now. So then it'll be there when it gets to it. Awesome. Basically, anything the browser can cache, can be prefetched. Async attributes on script tags are another great one that I found were like not well understood. Async will cause the browser to asynchronously download the file, but I think the real meaning, the real reason they call it async is it also executes those scripts asynchronously. So as soon as it has them, it'll execute them. So if you use async and the user already has that JavaScript cached because they visited your site before, it'll run it right away. And it won't continue parsing the document while that runs. So if it's something that's like takes a second, that can actually block rendering of your page. Defer, I like better, but no one seems to use it very much, so maybe I'm wrong here. But defer will cause it to download asynchronously, and it won't run it until it's done parsing the document. And it'll run all of your deferred scripts in the same order they're included in the document. So if one has to run before another to like set up some variables or something or whatever, you can use defer and they'll run in the correct order. And they'll run before DOM content loaded event. So that's pretty handy. So basically you kind of use these tools to load everything asynchronously. Once you're doing that, reduce the number of resources you're loading. So instead of having like 5 CSS files, try to make sure it's 1. And then only load the CSS and JavaScript you need. So like don't be having files with 97% unused CSS or JavaScript. This is as far as like everything I looked up on performance kind of went. I missed one thing, source set for images, but look that up if you want. Basically just you can give multiple image URLs, so like depending, like a media query, depending on the size of their window or whatever, it'll download a different image, like mobile devices can get a smaller image. I want to go a bit farther into kind of the junk we ran into when we were trying to apply this to a site that had been around for like 18 years at that, 19 years at the time. Obviously, like it wasn't on the original code base at all, but we still have a lot of cruft. So with an existing code base, it's really hard to take all these things and just apply it. So you already have CSS and JavaScript. You look at ours, like it's like 97% unused. That's because the site at one point, every page was formatted very similarly. And so we had like one kind of CSS for everything. Well, then we started building out all these features rapidly as like kind of MVPs to see if anyone wanted them. And the pages look drastically different. And all that ended up getting added into that because no one stopped to think, hey, we're doing things differently now. Maybe we need to engineer things differently. So we ended up with this huge CSS, most of it not used on any one page. And refactoring that, like I tried so hard. We couldn't. You basically we have to rewrite everything. And I'll show you kind of what you can get to with Lighthouse after you rewrite everything later. But for us, it wasn't an option because we had caught wind or whatever. Google basically said, hey, your search rankings on mobile are going to depend upon your mobile speed. So it was like, oh crap, we got to fix things quickly. We didn't have time to rewrite the whole system. So we kind of just looked at, okay, well, main goal is first meaningful paint for us. All that really matters, we need good first meaningful paint for SEO. It might still take 20 seconds for the page to stop spinning when you load it, but it needs to show up quickly. And if your site's kind of in dire straits with page speed, that's probably the same thing you should do. Get that first to kind of keep your company alive, then look at rewriting everything. So we did, I call it cheating. It starts off not bad. Don't worry, we'll get there. So we use Chrome, that coverage tool. Awesome. I can see what CSS is used on the page. Looking into it a little bit more myself, every time I see that a rule is actually used, I kind of poke around the page, see, is that used above the fold? Which means like without scrolling. Or is it stuff that's farther down when you scroll? Move all that into a separate file, focusing on the above the fold. And now we can use HTTP2 to push the critical CSS right away. So that's kind of a new thing in HTTP2. When you serve the page, the server responds and says, like, here's the document, and then it just starts sending things that it knows you're going to need. So you can just start sending that critical CSS right away. That's what I wanted to do. So I got it all separated. I wanted to send it with HTTP2. The other thing I wanted to do is load the CSS, use load CSS as a JavaScript library. It's mostly a polyfill, but like you go to their page and it is fantastic. And it tells you kind of exactly what to do to turn your normal preload into something that will load asynchronously and work in browsers that don't support preload. Yeah, handles all that compatibility for you. It swaps from whatever's there now to the new style sheet once it's downloaded. Great, does a lot of cool stuff for you. We did get that going for the bulk of the CSS, but our infrastructure doesn't support HTTP2, so I couldn't push the critical CSS initially. We also had other pages break when we pulled that CSS apart. And our critical CSS was still like 80% unused, but it was much smaller. So we just inlined the critical CSS right on the page. We also have this fun thing where we have a lot of traffic on our site. So for scalability, our assets like our CSS, JavaScript images are served out of a different cluster than the web cluster. So in our backend, we actually have to make a request to our assets cluster, which like we didn't have anywhere else in the code because it's just terrible, to get this file and then inline it in the document, which makes that time to first byte slower, which is terrible, but we're doing full page caching, so hey, whatever, who cares? Fixing other pages, I just use Webpack to basically combine that new file and the old file again, and hey, there's our old file again. That fixed all the other pages that broke. So we also really wanted to reduce the size of the critical CSS more. I gave up. That comes down to rewrite everything. So some more cheating we did. This one I'm actually kind of proud of. So normally with fonts, you can use the preload directive to say, hey, go and load this right away when page starts, and you'll be fine. It'll be there by the time the browser wants to display the page. We're using the Google Fonts API, or we used to be, and it works. It's a little weird. So it actually serves you a CSS file that includes the URLs to the actual fonts. The reason it does that is because when you make a request for that style sheet, it sends you a different one depending on your operating system and browser. The idea is those fonts are all slightly different so that it looks the same no matter what system you're on, which is awesome, but it totally screws with page speed because I can't do anything with that. I can't, I can preload the style sheet, but that doesn't help me a whole lot because it's still not going to load the font until it's done and ready to show the page. So that's a huge problem. We still managed to inline the font though. How? If it's different for every browser, like what we ended up doing is just looked up the most common browser OS combo for people hitting our site. And we just downloaded that font. One of our designers opened it up in a font editor, deleted all the symbols that are probably not going to be above the fold. And we made ourselves a new font that we then base 64 in code and dump on the document. And then we use load CSS, the same tool we use for the CSS, to swap the font from like, it was like simplified or like, just call it like basic dash the normal font name to like the actual one. So it kind of just changes the CSS to swap to the full one once it's downloaded. And on most browsers, you didn't see any, like even a flicker. Like it would show up right away, nice and fast, and then it would load in the full font. So if there was any weird characters lower down in the page, you don't even notice. It's the best font loading I've seen actually. Downsides to all this though, we're really wasting our users' bandwidth a lot by dumping all these things into the document, sending all this stuff we don't need. It's harder to maintain the code base. Now like the CSS for one page is in 2 different files, and like, what? It also removes an incentive to actually clean things up. Like if you're in this kind of situation, you're probably fighting for time to work on tech debt anyway. And hey, our business is going to go under because Google's going to drop our rankings is a pretty good way to get the business to be like, okay, yeah, you can rewrite things. But in an emergency, we sort of did what we had to do. So if you want to see some of that. So Look at the audits here. This one's better. So this was our site before. This is one of our old pages when it's not cached. So when it's not in the page cache. This is that same old page when it is in the page cache. So the first meaningful paint went down like 4 seconds. Pretty good. And this is around like 4 to 6 is where we were at before. Question?
Page caching?
Varnish. There's a video of my talk from 2 months ago with that. But basically it caches the full response from the web browser. And it caches it for 15 minutes and then it has like a 3-day grace period, which you can configure that to be longer. So if it's not in the cache, it'll still return what it had immediately to the end user, and then it'll talk to your backend to refresh that cache. So most of the time our pages are in the cache. That's why I was willing to like just dump so many things in and like make that server response slower, because it's like, well, we have a pretty good hit ratio on the cache. If you don't have a really good hit ratio on a page cache, you don't want to do that. But kind of the idea is like, don't be scared to get creative. If it's like, hey, our business is like going to have a huge drop if we don't improve speed, do what you have to do to keep the business running until you can actually rewrite everything, right? And now this is one of our pages in the new stack that we just launched like 4 weeks ago. First meaningful paint of 1 second. So this is with things done properly. I don't think there's any like, hey, reduce unused CSS or anything like that in here. A lot of the problems that are still there are related to ads. Ads are awful. They seem to not care about what they do to your site. So a lot of them will load things that are way too big. Let's see if it's actually in here. Yeah. This guy here, which is 95% unused and 1.6 million bytes unused. That's from an ad. Like the majority of the size of the page. We try to only use ad providers that have higher quality ads, but among the places that are higher quality, that's what you're looking at, and it gets worse from there, sort of. So the ad space has a lot of room to improve. You want to see? Yeah.
If you were starting from scratch, what would you do differently? Can you repeat the question?
If we were starting from scratch, what would we do differently? We didn't have like a atomic design, so there wasn't really the concept of like, hey, this is a component. This is all the CSS and JavaScript that it needs, that it can be self-contained. Things weren't done that way right from the beginning, so there's like a layout.css file that handled layout for like 7 different pages. It's like, once that's there with no comments, you go into it, how do you separate that out into like, oh, this is the article page and this is a term page, and this like kind of impossible. So that's a huge one, and that's what Dotdash's infrastructure or their framework is, all atomic design, all componentized. So it's really easy from the beginning to do things right. What else would we do? It would be really nice to build like the whole infrastructure around like modern technologies like HTTP2. We have that Varnish page cache that we rely on heavily to keep our site running. Varnish doesn't really support HTTP2. So yeah, that's just another thing. It's like part of it isn't that it's like, well, we made mistakes and now we need to throw it out. It's like technology has moved along, and a lot of the frameworks and stuff we're on just don't hold up anymore. So I don't think you can write a website and be like, yeah, for 15 years, we're never going to rewrite this. Like, it's not possible. Things change. You have to rewrite at some point. Page speed is just kind of a common topic nowadays because it's getting more focus from Google. So it's a big deal. So a lot more companies are focusing on improving that right now. This is the page source of our old site I'm running locally, and you can see here, where do we get to the inline? Oh, there's all kinds of junk inlined already. Where's my junk? There we go. I think that's getting into, yeah, I think that's the font there. Yeah. So yeah, when you view source, you can see it's pretty ugly. Oh no, is this the font? Yeah, that's the font. Yeah, source sans min there. Yep, there's our base 64 encoded font. So one of the things though that like I didn't feel as bad about doing this, because if you do HTTP2 push, you're pushing before you know if the client even has it anyway, so you're still kind of wasting their bandwidth and pushing it to them, even if you are using the modern technology. There are things coming down the pipe to handle that. You can do things like you can already do things like kind of setting cookies and stuff along with sending it. And then on your web server, you have to check for those cookies and you know like what resources they already have. But if they've gone and like cleared one of their caches but not cleared the cookie, then they don't actually have it. So there's problems with it. There's proposals in the pipeline to like add to the web standards so that you know, like when they make a request, it says like, hey, here's the resources I have for your site already. Then you can just push the ones that are needed. So it's not an ideal solution yet anyway, so I didn't feel super bad about the inlining some stuff. You know, all things considered, that is pretty small for a, you know, font. Anyway, that's my presentation. Thanks.